Hey everybody, Bill Sky, the assembly guy here for our third video on File.io. We're going to have two more videos after this because I want to talk about advanced file input and output in both Linux and Windows. But in this one we're going to do Windows. Now this is going to be a duplicate of the Linux one but on the Windows platform. So if you really want to get a good sense for what it is to do File.io on multiple platforms, I really recommend that you do that. Take a look at the Linux one too, and this one will be a little bit easier, not too much easier, but a little bit easier, simply because Windows is so different. So let's get right to the coding. So we're going to do the exact same thing we did in the Linux one. We're going to simply create a file, we're going to write to it, we're going to read from it, we're going to write a string, we're going to write some numbers. We might even be able to read a string back as well. We'll see if we have time to do that. But the first thing that you need to understand is that Windows requires you to prototype functions because you don't call Windows low-level interrupt functions through an interrupt as much as you do by calling functions themselves that Microsoft has prepared for you. So there's a number of functions that we need to set up, much like this exit process function. Now this is a 32-bit version or 32-bit MASM macro assembler project, and you can see the exit process prototype right there. That's so we can leave the program and have the operating system unload our program from memory. Well, there's a number of other functions that we need, and I'm going to go ahead and just copy and paste those in here. And what I will do is I will make these available to you in the description of the video. But I'm just going to paste them here because there's an awful lot going on here. There's an awful lot here to paste, and oh my goodness. So this is one of the reasons why I really don't like Windows programming very much, because of the amount of overhead to get all this done. So let's talk about each one of these functions. The CreateFileA function, that will actually, it's kind of weird, that'll not only create files, but it will also open files for read and write, and things like that. So it's not just create file, it's basically should be open file. Then you've got the CloseHandle function, and that's actually the close file function. That function takes the file handle that you'll get when you create the file or you open it for read, and it'll close it. Then we've got the WriteFile function, and then we've got the readFile function. And as you can tell, there's an awful lot of arguments here, and we're going to do that live in the program. So let's get right to that and take a look at these in the description. So what we're going to do is I'm going to write a string to a file, and first of all we need a string, and we also need a file name. So what I'm going to do is I'm going to create a file name called fileName, and I'm going to call it testfile.bin, and I am going to zero null terminate it. And that's really, really important because you need to have that information for the create file, especially in Linux. In Windows it might not be so big of a deal, but on Windows you need it but on Linux you need it for sure, but on Windows you need it as well. And then we also need the file name size. So I'm going to say file name size. Now you can't use length of like you can with other functions. You actually need to get the file name size, and we're going to create a variable for that. I'm going to define double, and that's going to be $-filename. So that variable is going to be used to send to the create file function. And what else do we do? Well, let's go ahead and create a string. So I'm going to create some string, and I'm going to define byte. This is some string data. And you might want to create a variable which is the size of that. So I'm going to say some string size define double $- some string. So we're going to use that to write to the file. So now we are going to need to have some handles, and handles are basically just pointers to the file. And you had this in C and C++ if you did file. You even have it in Java. So you have to have some kind of a variable that points to the file. So I'm going to create an output FileHandle. I'm going to define double. Now if this was 64-bit, you would define it as a quad. You're also going to need a couple other things. I'm going to go ahead and put an input FileHandle too, and I'm going to spell these right. But you need a couple other things. You need a total written variable, because the function actually needs that. When you call the write function, you actually have to provide them a variable. And then same with the read. So if you're going to read, if you're going to call the read function, you also need to have a variable that's going to contain the number of bytes that you read. Okay, let's just go ahead and build that. All right, looking good. Okay, so let's go ahead and let's open the file. Let's create the file, and then let's just immediately close it and see if the file does exist. So I'm going to use the invoke. So I'm going to say invoke CreateFileA. I'm going to get the address of the fileName variable. And then I'm going to do this. It's really frustrating. It's a really long number. So I'm going to go ahead and just put that in there. And this is the accessMode, which is generic write. And this one right here is the fileName. So I'll put these values either in the video when I produce it or as notes. Okay, so that's the access node. Then we're going to say 0h. This is do not share. Then we're going to put in another 0h, and that is security, none needed. We're not going to really do much with security. Then I'm going to say 2h. Now 2h means create always. That means if the file exists, create it. Now if there's another option, I believe it's 3h, that if you say that, if the file exists, just opens it for output. Or actually just opens it, I guess, for output. So I've never really used that one, but and then we've got 80h, and that will be file attributes normal. And then we make a 0h, and the last argument, that is basically template FileHandle. We won't need it. So holy Moses, where did I come up with all this stuff? Well, I actually had to log in to Microsoft as a developer, and I had to look at the API. And you can actually, I don't even think you have to log in, but you know, I'm a authorized developer or in their developer program, and I had to get all this information from there. This was years ago I did that, and it is still there. Now the one thing that the CreateFileA will do is it will go ahead and return in EAX the FileHandle. So I'm going to say output FileHandle EAX. Now if EAX has a 0 in it, that means that the file didn't open correctly. So you might want to compare EAX with 0, jump if equal to open error. And you might want to put that before you move the value into the open FileHandle. So we'll do a end all, and then we'll do a open error. And we'll just put a no op in there. You might want to put an error message or something like that in there. Okay, now let's go in and let's just immediately close the file, because if you remember, if you watch the Linux version, there's a number of things that you do. You open the file for output, which we've done. You process the file contents, which we have not done yet, and then you close the file. Now, if you didn't watch the Linux version, it's really important to close a file, especially when you have it open for output, because when you write data to a file, you're not actually writing it to the file on the storage device, you're writing it to a memory location. And if you don't close the file and your program ends, oops, you could lose a lot of data. So it's always important to close a file before, write it when you're done with it. So I'm going to go ahead and put these comments up there. And we haven't processed the file contents, but we're going to go ahead and close the file. So the way that you close the file is you use the CloseHandle function. So I'm going to invoke the CloseHandle function, and I'm going to send the only argument, which is the output FileHandle. And where did I get that? That came from opening it. So if I didn't get a 0 in EAX, then I actually got the handle. So I can close it. Now I'm just going to go ahead and save and build this. All right, looks good. Now I'm going to run it. Now I'm not going to run it from Visual Studio because where the output file goes is really kind of a pain in the neck. It's much more difficult than in Linux. So what I'm going to do is I'm going to right click on my project and I'm going to say, and I always have trouble with this because they always seem to move it. I'm going to say open file folder in File Explorer. And I'm going to go into debug. And actually, yeah, it's always kind of a mystery where they put it. So I went into Win86 file. I'm looking for the executable. And I see the object file. I'm still looking for the, okay, go into debug. Okay, here it is right here. So let me do that again. So what I did was I right click on the project and I say open folder in File Explorer. Then I actually went up. Instead of going into debug, I went into Win86 file IO. I go into debug from there and there's the executable. So I'm going to right click on that. I'm going to say open in terminal. And I'm going to do a dir, and there's my executable. So I'm going to type Win x86 file IO. And because this is PowerShell, it's not. So let me see what I have to do here. PowerShell is a little bit of a problem. So Win x86 underscore file IO. I think you have to say .exe on PowerShell. Nope. So let's try this. /Win x86 file.exe. That time it worked. So you have to say /. Now that's just like Linux. So I'm not expecting that from Windows. And if I do a dir, there's my test file. So it created the file correctly. Now I didn't put anything in the file because all we did was just open it for create. So what I'm going to do is I'm going to leave this window open over here. And let's go ahead and process the file contents. Now what I'm going to do here is I'm just going to print, I'm going to save this string, put that into the file. So the way that I'm going to do that is I'm going to go to my step number 2 here. Now the file is already open, or has already been created. So I'm going to say invoke WriteFile. And I'm going to say, okay, what is the file handle? That's the next argument. So I'm going to put the output file handle as an argument. The next one is the address of the string that I want to write. Now, where is the string? It is some string. Some string. And then now how long is it? So that's the next thing. When you write to a file, you have to specify how long it is. And that's going to be some string size. And then it needs to now know a variable that will contain the total number of bytes that were written. So I'm going to say the address of total written. That was the variable that created up here, total written. And then the last thing we want to do is we want to just send a 0. Because we're just not going to use that. We're not going to mess with that. Okay, so let's save and build that. Okay, it looks like it built. Now I'm not going to run it from Visual Studio. I'm going to run it from here. And I'm just going to press the up key. And now take a look. So we've got the test file before we did the write was 0 bytes in size. Now it's 24 bytes in size. So what I'm going to do is I'm going to type testfile.bin, and you can see the contents of the file. So that's a string. Now, what if we want to write numbers? So what I'm going to do is I'm going to comment out I'm going to comment out printing or saving the string, and I'm going to create a couple of integers. So let's create a couple of integers. I'm going to say int data1, define double 1, 2, 3, 4, 5, and int data2, define double 6, 7, 8, 9, 0. And we're going to we're going to save those to the file. Now you're going to notice that saving an integer or a number of any type, you can do a float, you can do a single character, a string, whatever you want. It's exactly the same way. You specify what the address is in memory that you want to save it to a file, how many bytes do you want to save to a file, and then you just issue the command. Now, a double is 4 bytes. If this was a 64-bit, you'd be doing 8 bytes. Okay, so let's take a look. All right, so let's do the exact same thing. Now this time I'm going to say invoke. Now actually, to keep this quick, let's just go ahead and copy. I'm saying it's the same, so let me prove it. So I'm just going to delete all this. And the output FileHandle is fine. Instead of some string, we're going to say int data1. We know how big it is, right? So I'm just going to put 4 in there. And we're going to leave total written. Let's build it. Okay, look like it built okay. Now let's do the second integer as well. So I'm going to copy this and paste it. And we're going to say int data2. And we're going to go back to our window and we're going to run it. And notice it's only 8 bytes in size because all we did was write 2 integers. I'm going to say type to display that number. And the reason why it looks so strange is because when you print something to the screen like this, it's expecting the contents of the file to be ASCII values. And if it's not ASCII values, which it's not in this case, it's going to just print garbage on the screen. So that's fine. Now, if you had a hexadecimal editor, and I don't know if I've got one here. Let me see. Yep, I don't think I have one installed on this Windows. If you had a hexadecimal editor, you could go in there and you could view the hexadecimal values, and you would see 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. You would see those 2 numbers inside of that file. Okay, so that's how you write to a file. Now that the file is out there, what I'm going to do is I'm going to comment out all of this write code. Including the write, the open, because we don't want to open it as create or write any longer. So I'm just going to comment all that out, and now we're going to leave the close there. So let's go ahead now and let's open the file for read. Now the code is a lot the same. It's a lot of the same, just different values. So I'm going to say invoke CreateFileA. I know it's weird, create file for read, but that's what it is. And we're going to use the same file name. I believe it's file name like that, wasn't it? Yep, it was a capital N. So we're going to use the file name. And now, because we want to do a read, it's 800, so it's 8 million, I believe, hexadecimal. And this is the accessMode generic read. The address of our file name. Okay? Now, we don't want to share the file, so a lot of these are going to be the same. The next one is going to be another 0. No security. We don't care for right now. We also want to say existing, so 3H, open an existing file. And we're going to say 80H. That's going to be file attributes normal. And then we're going to say 0H. Now we have to make sure we put that comma there. And this one here is templateHandle not needed. Okay, so that's going to open the file for read. We're going to go ahead and move into input FileHandle EAX because we need that later. And if you're wondering again where that was a simple double word that I set up right there. I put for output and input. We're going to use now the total read because we're going to read the data. So we went ahead and opened it. Now what I want to do is I want to move into my two integer variables 0h. Now the reason why I'm doing that is because I want to show you during debugging how it really does read the data from the file. I'm proving that the read works. Okay, so there's our zeros. Now let's go ahead and read the data from the file. So you're going to do another invoke. So you're going to invoke read file, and you're going to use the input FileHandle. You're going to get the address. So you're going to say, I want to read this into the int data1 address. So that's what that's going to do. I want to read 4 bytes. I want to put into the variable total read the total number of bits that or bytes that I actually read. Now the reason for that is because if you say that you want to read 4 bytes but there's only 3 bytes in the file, you can look to see, did I really read 4 bytes? And then I'm going to say 0h. So again, this is the FileHandle, where to read the file, number of bytes to read, how many bytes were actually read, and we're just going to say here not used. Now, I mentioned the total read. Here's what you can do. I can move into EAX total read, and then I can compare EAX with the value 4. Jump if not equal, read error. So that's how you can do it. If you didn't read 4, you asked for 4, but you didn't get 4, you've got a read error. So let's go ahead and put that in here. And we'll go ahead and jump to end it all. Let's make sure I get my capitalization done. All right. The reason I put this jump end it all here is because my program is really done there, and these are the little labels that I'm using for errors. Let's go ahead and build it. All right, now because we're not writing it, we're reading it. Let's go ahead. A little bit of a problem here, though, is that I actually, in the terminal, I actually ran it from this location, and so it saved the file there, but that's not how Visual Studio works. It's not going to run it from the location where the executable is. Great, right? So we have to do a little tricks here. I'm going to go ahead and uncomment all of this file creation stuff because we want the file to exist where Visual Studio thinks it's going to exist. So I'm just going to go ahead and let Visual Studio create that file where it needs to go, and I'm going to build it. I know it's confusing. I don't like it either. Okay. So let's go ahead and put a breakpoint right here on the move 0 into my data fields, and let's do the debugger. Or my data variables, I should say. All right, so let's go ahead, ampersand int data1. Let's right click on this and let's say 4-byte integer, and there's our 1, 2, 3, 4, 5, and there's our 6, 7, 8, 9, 0. Awesome. Okay. So let's go ahead and step over and zero those out. You can see how they both zeroed out. Now we're going to read the file, and we're going to read it into int data1, 4 bytes. And let's see what happens. It did not read it. My goodness, let's take a look at EAX. EAX has 0, so we actually have a problem. We did not get that did not read correctly. So let's go ahead and step over. Yep. So read error, we had a read error. Perfect example of why you might want to check that out. Now I believe the reason we had that read error is because we didn't really close the output file, because we just used the same close as we did for the output that was used by the output for the read, so we never closed the output file. So, and that's another good example if you need to close your output file. So I'm going to go up here where we create the file. There's WriteFile, WriteFile. I don't want to write the string, so that might have also been a problem. So I'm going to comment out the write string. I'm just writing the numbers. And then from right here, we're going to go ahead and close the file. Perfect example of what not closing the file will do to you. All right, let's make sure our breakpoint is on our 0 out. Let's debug it. We're going to go ahead and look at int data1. There's our two numbers. We're going to step 0. We're going to read one. Still didn't read it correctly. So let's find out what our error was there. Oh, well, look at, we're also closing the output file handle down here. So we should be closing the input file handle when we read it. Let's make sure we're using the input file handle. Oh, did we put that in there? Input file handle. Yep, we did that correctly. All right, let's build it again. Debug it. There's my int data1 zeroed out. Let's see if this read works now. It still doesn't read, so we've got a problem here. Let's take a look at total read. Yeah, it read 0 bytes. It may not be finding the file. Did we check the file to see if it opened correctly? Let's do that. Nope, we didn't check the file if it opened correctly. So what we're going to do is we're going to compare ex was 0, jump if equal to open error. Let's make sure our open error is there. Yep. So let's see if it opened correctly. Well, it looks like it opened correctly. It looked like it found it. But we're having a read problem. So let's go find that file. I'm not really sure where it put the file. So I'm going to right click on the solution and I'm going to say open folder in File Explorer. And let's go find that bin file. So I'm going to go into debug. Oh, there it is right there. It looks like it's 1,000 bytes in size. That's kind of unusual. So I'm going to right click on this. Oh no, that's the bin file that we used when we ran it from the terminal. So let's go up to this directory right here. We're looking for, there's the bin file. It's 1K. Let's go ahead and right click on this and open in terminal. And let's cat that out. Okay, it looks like the data's in there. Let's see where we can find that file. Well, unfortunately, PowerShell doesn't do searches like the command line used to. Okay, interesting. So let's take a look. So we opened it, jump if equal to open error, okay. We close the output file. Let's make sure we were writing it to the output file. Yep, we wrote both of our integers. We close the file. Now we create the file. It looks like this worked because it didn't jump to open error. So we copied EAX input file. We moved 0. We invoke read file input FileHandle, the address of integer data. We want to read 4 bytes. Oh, I see what happened. Well, no. We only read one. We probably would want to do this twice, right? One for int data 1 and one for int data 2. I don't think that was the problem. So after a few little checks, I found out that I left out a 0. I had 8 million and I needed 80 million. Now, how did I figure that out? Well, I went up here where I created it, and I simply counted these, and there was one extra 0 left. So I went ahead and put that on there. So it opened it, but it didn't open it for the reason I thought it was going to open it. So let's go ahead, or the way that I thought it was going to open it. So let's go ahead and run it. We simply changed it from 8 million to 80 million. Let's put our ampersand int data 1. Read it. There's our 1, 2, 3, 4, 5. It's equal to 4, so it worked. Read it again. There's our 6, 7, 8, 9, 0. It read it, no problem. And now we're going to go ahead and close it. You can also read a string in this fashion. So if we had written just the string, we could have specified that I want you to read up to this many characters. Now, one thing I put in the comments in the production of my Linux video was that you, as a programmer, you have to keep track of the exact number of bytes that you're reading and writing to the file. So if you're using commas to separate your data, if all of your numbers are 4 bytes wide or 8 bytes wide, then you can read 8 bytes. But strings also have to be a specific length. Or you could separate them by commas, or maybe separate them by a null. A null terminated character is used quite a bit, like here on the file name. So you have to do that as well. You have to think about it. You really have to think about your files and how you're going to produce them in your program before you do. So that means design. You have to design it. And it's the same for Windows as it is for Linux. So that's it. That's our example. That's our demonstration of FileIO on Windows. In the Windows video comments, I'm going to have a lot of stuff in there for you to take a look at what it is that you need to do to call these things. I'm going to have all the prototypes in there, but that should get you started. And the follow-on to this video is going to be both a Linux and a Windows video on advanced FileIO, which could lead to random FileIO, dynamic FileIO, where you can pick where you want to read, when you want to read it. You don't have to do it sequentially. But we'll talk more about that in the next video. I hope to see you there.